Hello everyone. In this rather quick video, we are going to introduce the idea behind union find, which is a quite unfortunate name for a data structure that we're going to be using. This is a data structure designed to represent distinct sets. So let's write that down for ourselves. This is a data structure designed to represent disjoint sets, which hopefully we remember what those words mean. Sets meaning everything is unique, and disjoint meaning that there is nothing that exists in two of the sets at once. One particular application of this is not a particularly fascinating one, but maybe you want to represent the connected components of a graph in a set notation instead. So maybe you had some graph. I'll draw several nodes here. And maybe this graph has two different connected components, and you want to describe those connected components in a more simple way. A union find data structure might be one way to accomplish this. We'll understand it by thinking about what operations can we do with this data structure. There are going to be three primary operations, arguably four, that we will use to talk about this data structure. So, one of the operations will be the idea of making a set out of a thing, which creates a set containing only X. That's one of the operations. We're then going to be able to union two sets together. Union XY finds the union of the set containing X and the set containing Y. Notice that X and Y are not sets. They are elements that exist in some set. So we're saying whatever set X exists in and whatever set Y exists in, we're going to combine those two sets. We are not combining a set X and a set Y. So that is a peculiarity of this data structure that we need to be careful with. Another operation that we have is in same set. X, Y, which returns true if they're in the same set. It's not a particularly inventive function. Returns true if X and Y are in the same set. And then another one which is roughly the same as in the same set, which is going to be find set X, which returns a representative element from the set containing X. For those of you that have taken some proof courses and have maybe discussed the idea of equivalence relations, this is something like a representative from an equivalence class defined by an equivalence relation. The equivalence relation here being in same set. So this has some nice mathematical theory underlying it in that sense. Outside of that, these are sort of very simple operations, and almost all of the code we will perform with union find will also be simple. We won't write the implementations of these yet because we'll actually have two different implementations of the union find data structure. One of those will involve linked lists, and another one will involve trees. Neither of which is too bad. We just need to be a bit careful in the analysis of those implementations that we will analyze. For the linked list, that analysis there will be slightly easier than the analysis for the tree. But the tree analysis is mostly just verifying our code does what it says it does. That's going to be the difficulty there. That's all we have for introducing the data structure. In our next couple of videos, we will discuss how we can